So some of you may have seen a recent report from the Wi-Fi Alliance. They did a survey, and according to their results, 8 out of 10 people would rather ditch their iPod than give up their Wi-Fi network. When they surveyed the same group, asked them whether to trade between their home phone and their wireless network, again, 79% would rather give up their phone than their wireless network. So surveys and statistics, you can kind of draw your own conclusions, but I think it's safe to claim that people are really attached to wireless networks. So why is that? I think the simple answer is simple connectivity and easy connectivity. Connectivity is compelling, and whether your personal addiction is email, IM, online gaming, or MySpace, you need to be connected. And also because it's compelling, people are willing to take risks to get connected, to get online. Sure, it's an open, unsecured network, but I'm going to connect anyhow. So in this room, we see people on the wireless network. You even see people at DEF CON on the wireless network, even though the risk there is, say, 1,000 times higher than would it be in a normal coffee shop. So we may be feeling okay in taking that choice, making that decision between risk and benefit, but do you feel equally sure that the people you advise or the users you manage, when they go out and make that same decision? We need to make sure that their connectivity choice today doesn't come back and bite them a week or a month down the line. We need secure networks that are easy to set up, but we also need to make sure that when users move out of that secured environment, they're also protected as much as we can. Today we're going to give you a short look at the Vista stack. We're going to look at into the components, look at some of the changes we've made, but we're primarily going to focus on the extension points, the pieces we've added that allow you to build on and extend the stack and build security tools on top of what we've already done. So we're just going to give a brief introduction, just some small piece of background. We'll take a look at the various software components in the stack, and we'll look at the behaviors, how that software stack interacts with the user and how it interacts with other wireless devices. And we'll have time for question and answer at the end. This isn't quite the same as was published in the conference CD. We just had too much material in that presentation, more than we can get through, and we actually want to do some demos rather than just flip through slides. So we're actually going to show you some tools built on top of the stack. And the tools are changing up to about an hour ago, so hopefully they're going to work. So it's pretty obvious to everyone why you'd attack wireless. You find wireless networks everywhere, you're going to find someone using it, so there's a possible victim. I've classified wireless attacks into kind of two buckets. The first one is protocol attacks. Here we're looking at either a vulnerability in the specification itself or just how vendors implemented that protocol. And behavioral attacks are looking at the kind of next layer up, how the actual logic on the device works, how it does things like its auto-connect logic, how it does network discovery. So with two classes of attacks, we have kind of two approaches we've taken. For protocol exploits, well, the protocols in Wi-Fi 802.11 are all standards-based. So we need to make sure that the standards bodies are evolving these in a secure manner. And we try to be active in both the IEEE and the Wi-Fi Alliance. We're trying to choose secure defaults. So whenever the stack is making a decision on behalf of the user, we're going to try to do it securely. So if we see a network that advertises WPA2 and WEP, our discovery engineer is always going to try WPA2 first. And then we're just going to try and whatever best practice we have in design, coding, and testing, we're going to try and apply that to our body of code. And make sure that all the protocol parcels we have are as solid as we can get them. Behavioral attacks is all about the upper layer implementation. So here we're looking at known attacks. So if there's a paper or a report issued, we want to take a look at it, see what we can learn, and see how we can address it in our code. What I mean by promoting secure defaults is whenever we give a user a choice, we're going to make sure that the most secure option is the first one. If there's a set of dialogues where they can say click through, just by hitting XXX, or where they can cancel out of, we want to make sure they end up in a secure state at the end of that. What we're really trying to avoid here is any opportunity for them to become insecure through inattention. It sounds really obvious, but there's a lot of software out there that doesn't do that. If they do decide to make an insecure choice, we want to try and inform them of that risk and what potential impact there is. And we want better manageability so that if you're responsible for the set of client machines, you've got some control over, you can constrain what kind of networks they can attach to, where they can go. So why would we want to rewrite the wireless stack? Mostly it's down to feedback. We hear requests for features from customers, from OEMs and partners. We've had feedback from the community itself. We've had the rogue attacks from K2 and Dino. Simple Nomad did some stuff on ad hoc. So we try to take all that into account and bring it into what we've done. In fact, this whole talk is based on we had a whiteboard chat with Beetle one day, and this kind of talk evolved from there. If some of you may have seen the earlier talks on process changes and new tools, so we try to make sure we apply all those to the new software stack. And then the standard bodies are marching along on their own. There's a whole alphabet soup of 802.11 protocols. There's N, K, D, it just goes on. So we need to make sure we roll some of those back in, and we also want to make sure that the platform is extensible so that as new protocols and new features come along, they can be brought back into the stack without having to do minor changes with minor changes, not having to do a complete revision. So our goals are pretty simple for Vista. Obviously, we want to make it as secure as we can. We want to make it more manageable. We wanted to make it extensible, so there's APIs, information being rippled out, so you can look deeper into the stack than you could before. And again, transparent, so a lot of the information that was kind of locked down in drivers before, it's available to system services, it's available to applications. So now we're going to take a quick look at the architecture. We're going to look at XP first off to kind of set a baseline, and then we'll talk in more detail about what Vista does. So this is the basic architecture for XP. There are 3 layers. There's drivers at the bottom running in kernel, there's a service layer running above it, and then there's a user application, a user interface on top. So a kernel mode driver, in XP, the driver basically implements the entire .11 stack. Both the Mac and the Phi are all done in the driver. It's an emulated Ethernet driver. By that, I mean it plugs into the rest of the stack as an Ethernet device. So part of what the driver does is also it's translating the frames between 802.3 and 802.11 as it passes them up and down to the stack. So that basically the driver is implementing all of the standard Ethernet OIDs. It appears to the rest of the system just like an Ethernet driver, except that the driver also implements a handful of additional wireless specific OIDs. So OIDs are object IDs. These are effectively buffers that get passed up and down between the driver. So you can think of these as the application interface to a driver. So the set of wireless OIDs are responsible for things like scanning, connect, disconnect. Above the driver, we have our wireless zero config service. So this is the guy that's actually driving those OIDs. It's talking down the driver, and it's using a special function protocol stack called Anderseon to actually communicate up and down with the driver and push these OIDs up and down. The service is responsible for the auto connect logic. It also is responsible for like manual connection, pushing things like scan results up into the user interface, to going between the service layer where there's always on code running into each of the user contexts. And it also contains the 802.1x supplicant. It has some interactions with DHCP and some limited interaction with group policies, so you can push down some configuration to the service. And finally, on the top, there is the user interface components running in the context of the logged on user and communicating back and forward to the service through LRPC. So the XP design is pretty good for what it was intended for, which is connectivity. There's some things we can do better, and there's some changes that will come along in service packs. But basically, it's intended just for that connectivity. The core problem with the XP design is it's really pretty much a black box. Packets come in, packets go out. You get some kind of user interface notifications. But if you wanted to write an application that sat on top and drove wireless, you can't really do that unless you wanted to go and reverse engineer the RPC interfaces. It's quite common that enterprises will deploy Cisco equipment, so they might want to use Cisco CCX security. You can't add that into our client. If you want to have that, you've got to rip our client out and put it in a separate software stack. So that we really want to kind of get away from that model in Vista and trying to open these pieces up as much as we can. So this is the Vista architecture. It looks pretty similar. Still got those 3 big layers, drivers at the bottom, an expanded service layer, and then some more options at the top in terms of user interface and applications. What we're actually going to do is we're going to drill down a little bit into each of these layers and talk in a bit more depth, and then we'll show you some demos at some of those layers. So the first level that we're going to talk about is the stack. We're going to start from the bottom, work up. We'll look at the drivers first off. So one of the things you'll notice is we actually have 2 driver models. There's the existing drive model, exactly the same as you saw in XP. So we have that model in there so that older devices will still continue to work. We refer to that as the FAT model. FAT isn't an acronym for anything, it's just that these are large bodies of code typically. But we also have a newer driver model. So on the left-hand side, you'll see that effectively we've broken that driver model into two. At the bottom layer, we still have an IHV, a hardware-specific drive, mini-port driver. This is doing the PHY and the lower MAC functions. But actually now, rather than exposing 802.3, it's actually exposing 802.11 at the top end, and it's binding into a Microsoft driver. So this driver, the driver layer, is then common across all hardware. This driver layer does the upper MAC functions, and it also does that translation between 802.3 and 802.11, so it can plug into the rest of the stack. And again, all of this stuff is running inside NDIS, which is NDIS is the kind of standard driver interface for network cards. NDIS is responsible for things like driver lifecycle from installation. You can run co-installers as you install a card. It's responsible for the binding, so it's how the stack and the drivers connect together, and how we multiplex packets up and down through the stack. So I mentioned we were going to talk a little bit about some behavior changes as well. So this is one of the first ones. So in XP, any network that's in our preferred list, we actually send out a probe for that. The problem with that is all those probes for every network, every you visited, get exposed on the air, and there's a potential for an attacker to spoof those networks and try and get you to connect. We made some changes for this in Vista. So by default, we don't issue probe requests anymore, unless you've actually got a network that you configure to be non-broadcast, so you try to hide it, in which case we have to send a probe to actually find that. But that's the only case we'll actually send a probe. Another similar change we've made is when you resume out of hibernate or standby, we're actually going to take a look on the air first to see if we saw the last access point we're at, rather than just sending out some probes or some traffic for it. And that's just to try and stop us from leaking the last network you connected to. So again, just to try and make the client more passive, release less information than we did previously. So there is one kind of big side effect to this. It's pretty common advice out there to actually hide your home network's SSID to make it non-broadcast. It's always been pretty marginal advice because it doesn't work the moment someone sends traffic, but it's fairly common. But now it's really going to be counterproductive, because if you do that, your client is going to, if you travel around, you move your laptop, your client is actually going to be probing for that network, whereas if you'd made your home network broadcast, you wouldn't actually see that at all. Similar effect we have in SP2 is if we don't see any preferred networks we want to connect to, we try and park the card. And we do that currently by plumbing down a random SSID down to the driver. The problem again is because we're probing for everything, that random SSID gets pushed out and there's potential for an attacker to spoof it. Vista, we've taken two approaches to fix that. The first one for the new driver model for native Wi-Fi, we actually have a specific OID, a command that goes down to the driver to say, just park, wait till we tell you to do something else. For the older drivers, for the FAT model, we still push down that random SSID, but now we also push down a random key. So although the attacker might see that network, they actually won't be able to get the client to attach. NDIS ports is it's a very geeky kind of developer change, but we like it. In previous versions of the OS, the main piece of connectivity information that rippled up to say you're now connected was a media connect event. That's very much a kind of legacy event from the days when simply plugging into a jack in the wall was sufficient indication that you could flow packets. With wireless networks, more connection orientated, where we have layer 2 security, that's really not the case anymore. So part of the problem that caused was at upper layers, we had to have a tight couple in between a bunch of the system services. So DHCP and wireless had to talk together to make sure that we kept the state and the traffic that was going up and down through the stack was going at the right time. That's really not the best way to design it. So what we've done with NDIS ports is we ripple that information up and down through the stack. So NDIS port information includes the raw media connects, but it also includes information about power state and the authentication state. So now we have a much cleaner way to indicate up to system components what the state of that connection is. It now simplifies the design at the upper layers, and it also makes sure that there's much less chance for us to actually leak any information inbound or outbound before that connection's properly authenticated. So what can you mess with at the driver layer? The first one is you can actually do drivers. So previous versions, most people that wrote drivers are actually hardware vendors. In the Windows driver kit we've released for Vista, there's actually a full sample for a native Wi-Fi driver, for a wireless driver. This isn't just a set of code samples and functions. It's actually a fully functioning driver, and it works on real hardware. It works on the Realtek chipset. These cards are pretty available. In fact, our local CompUSA probably sells more of these than any other one in the country. You can take that driver, you can mess with it. If you want to do some 2.5 layer mesh, you could mess with the driver and do that. If you just want to do something malicious with 82.11 packets, again, you can modify the driver and do that kind of stuff as well. So there's a lot of flexibility in that. You've now got a real working driver on Vista. There's full code for it, and there's easily available hardware. Also worth noting, because it is the sample driver, although this is based on Realtek hardware, a number of the other vendors basically took that same design, so a lot of the other drives out there are very similar to it. Another interesting area to mess with is because we've now got that 802.11 layers natively open in the system, you can actually put filter drivers in there. So when you send a filter driver between the IHV mini port and the Microsoft driver, you can now see all the 802.11 traffic. You can see packet flows. You can see all the command and control stuff going up and down. Typical things you want to do with that is obviously any kind of protocol analysis. It's much easier now. And intrusion detection. If you want to do any kind of intrusion detection on the client, if you want to build, say, a distributed intrusion detection that works on all Vista clients, you can actually now get at that information. You can build those sort of tools on the platform. You couldn't do that in XP. So this is obviously a great toolbox for developers to play in, but it's not a free-for-all. You do need admin privileges to actually install drivers and to modify bindings. So this is, if you've got privilege on the box, you can do whatever you want, but it's not it's not exposing additional attack surface. It gives you the ability to write attack tools on Vista, but it doesn't mean you can just go in and install a driver randomly on someone's box. So actually, we're now going to, Tarun's going to actually do a demo, basically some of the stuff we've done at that layer. We've knocked up some samples.
All right, thanks, Noel. All right, so Noel spoke about the enhancements that we have made at the driver layer, and I'm going to talk about one of the ways in which you can do it. I'll just do it by an example of writing a .11 packet sniffer. I bet a lot of you have used packet sniffers in your research. Some of you might be running it right now. This is a great tool just to experiment on Wi-Fi, to debug some hard-to-find connectivity issues at Wi-Fi, and just a good tool to do security research. So Vista makes it extremely simple to implement this tool compared to XP. And the primary reason for that is on XP, Wi-Fi integrated as an Ethernet media. So all the rich information, all the .11 packet headers and other state at the .11 layer was really lost. We had no idea of getting, or no way of getting it. But with Vista, because Wi-Fi integrates as Wi-Fi, so we can see the .11 headers, we can also see some rich information that is happening at the mini port layer. And as a result, you can write monitoring tools similar to the one that we are going to show right now. So the way I implemented this is like a filter driver, which sits on top of the native Wi-Fi mini port driver. And to get started quickly, I started with the sample filter driver that comes with Endis WDK. I made two changes to this driver. First, I modified it so that it only installs on top of Wi-Fi devices, because we are interested in Wi-Fi here. I also modified the send and receive routines of this driver, of this filter, so that it makes copy of every .11 packet that it sees, and it dumps it to a file. To start capturing, it does a couple of OID calls down to the underlying miniport driver, and that includes setting the driver to the required file type, that could be 11A, B, or G, setting it to the desired channel on which you want to see the packets, also setting it to a new mode that we have defined for Vista. It's called the monitor mode, and setting a write packet filter. For the demo, I'm going to set it to indicate all the packets, but depending upon your needs, you can set it to whatever kind of packets you want to see. Once you have a capture, well, you can use different kind of tools to view it. We use Microsoft Network Monitor 3, but you can write your own custom application that can parse these packets and show it to you in a nice way. So what I'm going to do now is switch back to my Vista box and just take a live capture here. So just give me 1 second, I can't switch directly.
So you'd have seen this kind of stuff with Etherreal before. It's very easy to do this kind of stuff on Linux. On Windows, you'd probably have to install PCAP. You may have had to have specific hardware There's only a certain number of drivers that will do this on Windows. And now with Vista, because this is actually part of the driver model, you can pretty much do it on any box.
I hope you can see that. Yeah. All right, so what you see first of all here are the adapter properties. I have a Realtek adapter in my box, and you can see that the filter driver that I was talking about, it is installed on this. So just wanted to show that to you. I have also written a small tool called WL test. You can see it's reporting one wireless adapter here, which is Realtek. And let's take a... Okay. Let's... Do you know how to change the font here?
Just go into one of those.
Yeah, I think this one should be fine. Is that better? Okay.
You can't actually see the screens from here. So
Yeah,
really
that's
like.
why I can't change it to the... Let me just go back to this one. It's back to what it was. Is that okay? Can you guys see? Oh, okay, all right, I'll switch to the other one. Sorry about that. Oh, Lucida console. Oh, this one right here. Okay. And 16 or 20? All right, that's better. Thanks. Sorry about that. Hope that's better. Okay, so I have this small tool called WL test. All it's going to do is instruct the driver to capture packets. I'm setting it to mode 1, which is monitor or get all the packets. You can also write tools to just see the packets without disconnecting from anything, where you will only see the packets which are destined to your machine. So we're going to see every packet, so I'm setting it to mode 1. Let's set the file type to G. Let's set the channel to, actually I'm setting it to 0, which means it's going to scan over every channel, and it's going to stay on each channel for a couple of seconds. Say I can sit on every channel for 5 seconds, and let's collect the capture in foo.cap. So the counter that you can see at the bottom of the, I hope you can see that, at the bottom of the screen is the number of packets that we have captured on each channel. And it's going to stay, as I said, for 5 seconds on each channel and move to the next one. So we'll have to wait till it scans all the channels till 11. So while that happens, I wanted to point out that it's extremely easy to add this capability on Vista. It wasn't that easy on XP. And the primary reason for this is the way we have defined the driver model. For instance, the code that was required to add sniffing capability was like about less than 1,000 lines of code on top of the filter driver. Another thing which is really great about Vista is the fact that this capability can be done on any kind of Wi-Fi adapter. I know there is some kind of sniffing capability which is there on Linux and other operating systems, but they kind of are limited in the sense they only work with certain hardware. Here, all the interfaces that we are using to do this are standard interfaces. They're required for every device which integrates with Vista. So I'm just going to stop the capture because we've scanned all the channels. So once we have the capture, we can view it in any kind of packet monitor tool. I'm just going to load it in Network Monitor 3. Again, I'm sorry for the font. I'm not sure whether it's completely visible. So here, let me just try to increase it a little better. So this is the next version of Microsoft Network Monitor. Some of you might have used it on XP by the name NetMon. What you see here is a summary view where you can see a lot of interesting information. For instance, you can see the rate, the RSS, the rate at which the packet was received, the signal strength with the packet was received. So this is some of the rich information that we require every driver to indicate with the packet. And we have been able to capture this information along with the packets. And of course, you can look at regular .11 stuff. For instance, we have been able to capture data frames, control frames, and management frames. So let's go down here. Yes, so you can see management frames, control, and data frames. Then some other .11 fields just in the summary view, like CTS, RTS, beacons, Wi-Fi source and destination addresses, some other rich information about Wi-Fi. And of course, you can select a particular packet. Let me just increase this window. You can select any specific packet, and you should be able to go deeper into that packet. So say I'm going to pick up the beacon packet, and we can expand it further. If you guys are familiar with the .11 protocol, you'll really appreciate this. So there is some metadata along with this. Then of course the standard .11 fields like the frame control, the packet is to DS or from DS, source destination, BSS ID, sequence control, then the details of the beacon, the information elements in the beacon. So there is a lot of rich information here. You can see the rates so this is the Black Hat AP that Aruba has deployed for this conference. And you can see there are some mandatory rates that the AP is supporting. There are some standard rates the AP is supporting. It's also saying that non-802.11g stations are present right now. And of course, there is FCS of the packet. If you want to see the packet in raw format, you can of course see it on the right-hand side here. So the reason we use Netmon 3 here was again because in the new version of Netmon, it's extremely simple to add support for new protocols. The Netmon that we have right now does not have support for Wi-Fi, so I had to write a Wi-Fi parser here, but it was quite easy in the framework that they provide in Netmon 3. So I'm just going to quickly load up the parser here. So, well, the entire .11 parser, for instance, is described in the NPL language, and this is, I don't know if you can see this, but this is less than 1,000 lines of code again to write the .11 parser. So go check out Netmon 3. It's available on connect.microsoft.com, and it's also a great tool. So anyway, let's get rid of this. So once you have the capture, you can analyze it, derive some useful information out of it. You already saw a demo yesterday in the other device driver talk where they were able to look at the capture and in fact deduce what kind of hardware that Wi-Fi devices were using. I just wrote a small tool. It's just a toy tool. All it does is it's going to work on the capture file that we just took. That was foo.cap, and we are going to generate some kind of a graphical representation of it. So let's go ahead and launch this. So this was just out of the, sorry, let me just fix this here. This was out of just the 1 minute capture we took here. You can see there are 6 access points here. You can see which clients are associated with which AP. You can also see some other APs to which no other clients are associated. There's a Linksys and a Netgear, nobody's connected to that. You can see 2 ad hoc networks here. You can also see other 20 clients. You can see their MAC addresses, you can see what they are capable of, the channels that they are working on. You can see the networks that they are probing for. So for instance, you can see somebody with Tsunami and other networks that the different devices are probing for on the Wi-Fi network. So anyway, this is just a toy example, but the point I'm trying to make is that Vista provides a very rich platform for you to write a lot of monitoring tools. I mean, this you could have, and this is not a lot of information here, but just an idea that you can build more monitoring and packet analysis tools and intrusion detection tools on top of Vista that will be able to identify whenever a Wi-Fi attack is in progress, or that will be able to identify some kind of attacks against the network or misbehaving devices on the network. So also suppose you do write these mitigation tools, you do write some intrusion detection tools on Wi-Fi for Vista. We also have very tight control over the Wi-Fi device drivers in Vista. So you can easily, or you can relatively easily mitigate against some of these attacks on Vista compared to any other operating system, including Windows XP. Just to give you an example, the number of interfaces that we have with the Wi-Fi driver on XP is, for instance, about 20 interfaces. However, on Vista, we have a lot more. We have about 150 or a little more than 150 interfaces with the underlying miniport driver. So as a result, we have very tight control of the behavior of the driver, and there is a lot of room to experiment and write a lot of interesting tools. So for instance, I'm just going to bring up this file here. I obviously can't go into the details of this, but this is just the driver interface header file. And I'm just going to quickly move over the file just to give you the idea of how many interfaces we have. There are about 150 interfaces. All of this is documented in WDK. And you can also download WDK and look at this header file to get an idea of how you can interact with the driver. So there are about 150 OIDs here. So anyway, these were some of the enhancements and some of the possibilities in which you can extend the Wi-Fi at driver layer and build interesting tools out of it. Noel is going to talk next about some of the enhancements we have done at the service layer and some extensibility that we have tried to provide there.
Okay, so I'll just try and switch back. This is actually an engineering sample of a laptop, so I hope the video comes back without blue screening. Ooh, I'm shocked. So, as Drew just showed, there's a lot more exposure at the driver layer in Windows than ever before. A lot more stuff you can mess with. But we've also expanded on the next layer up at the services layer. So if you look at what we've got in Vista, It's very similar to XP in that there's still a core service. It's now called the wireless order config service. It's doing the same kind of management, managing preferred lists, the order connection logic. It also has the 1x supplicant still in it. We have kind of expanded stuff in terms of hack managers and profiles. Profiles are much easier to use. We now have an integration with the Windows logon process. That actually changed a lot in Vista. We got rid of the old Gina model, which used to bring a lot of third-party code and load it into some pretty important system components. We've now got a new architecture that does credential providers. Well, basically, we plug into that so that we can get, if you do a login to a Vista machine, we can get those credentials that you're providing to Windows, and we can provide them to 802.1x at the same time. So we can actually do a synchronized login to the network. This addresses a bunch of different customer scenarios where they want a tight network control. Another interesting area we've got is we've got extensions into diagnostics. So Vista has a rich diagnostics framework. For example, if I go home and my wife had changed the WPA2 key on my network at home, if I just connected blindly, I brought up our IE, I'd get a 404 error when I try to go to a page. I can hit diagnose in IE, and then we'll actually go and ask every layer in the stack below it if there's any kind of problems. And it'll derive this fault tree of all the potential problems and try and ask each component in turn if you've got an issue. So finally, it'll get down to the wireless layer at layer 2. It'll say, well, it looks like there's a mismatch key problem. It'll provide back a set of possible resolutions, and those will be presented back to the user. In this case, they'll actually be taken to the UI where they can go and change the key. The other area we've done a lot of work is kind of in extensibility. So there's IHV extensibility where you can add a code that can modify either security or the connection process, and then some more abilities to add new EAT methods into the system. So if you saw John's talk earlier, he talked a bit about things like service hardening and some of the changes we've done in process. So again, our services had to go through that, and we made a few changes. In XP, wireless order config is an always-on service. It's running on every single box. And one of the core reasons for that is it manages wired 1x as well as wireless 1x. There's no discovery mechanism for wired, so it's there all the time. In Vista, we made some changes. First off, we separated the two services apart, so there's now a separate service of managing 802.1x on wired networks, so you've got more control over what's running. It's optional on server SKU, because there's not that many people that really want wireless on server. And also, we got it in this co-installer, so you don't actually start running the wireless service until you plug in a wireless NIC. Yeah, sounds kind of obvious, but we didn't do it before. We've done some privilege changes. So in XP, we run as local system. It's a very privileged account. We still need to run as local system now, because we need TCP access. We're doing things like manipulating credentials. We're doing conversion between a desktop session ID and a user account. So these are very privileged operations. That said, we have kind of taken the privileges we got and we stripped out, we've given away all the ones we don't need, so we don't need debug, stuff like that. We actually get rid of those when we start up. And we've moved it to a network restricted instance. There's no need for our service to ever be sending, we're layer 2, we don't need to send layer 3 traffic, we don't need to do sockets calls, so that we actually block that. So there's no valid reason for our service to do that. And finally, good advice, neither one, if you don't need to use wireless, just turn it off. But that's actually a huge generator of support calls to Microsoft, to the OEMs, and to enterprise help desks, because people turn off the wireless switch when they get on an airplane. 5 hours later, when they get off the plane, they're trying to do something, they can't figure out why it works, because they got the little button turned off. So actually, diagnostics, one of the simple things it does, it'll actually tell you that the reason you're not getting anything happening is you've got to turn that button back on. You're all familiar with rogue APs, so we've made some changes in Vista for this. We don't auto connect to unsecured networks anymore. And also, before association, we do a much tighter capability match between what the network advertises, what the driver capabilities are, and what we actually ask for in the profile. Plus, if there's a 2 access points, one a secure and one an insecure version, they're both broadcasting the same SSID, we'll actually make sure they show completely separate entities in all the UI, report it separately through the APIs, so there's no chance of those being folded back together. Evil twins, really similar. You try and spoof someone onto ad hoc, lure them onto ad hoc with an infrastructure name. Again, we never auto-connect to ad hoc networks anymore. That's one change. And the second change is we have tighter coupling in terms of networks identified not simply by the name, but a tuple of SSID, what the security settings are, and whether it's infrastructure or on ad hoc mode. So profiles are now just blobs of XML. It's probably easier if I just show you one. So this kind of stuff you'd expect to see, information about the SSID, the name, the hex string, whether it's a ESS, meaning it's in infrastructure mode, you'd see if it's ad hoc there, whether it's manual auto connect, and then security information. This is an open net, obviously this is the Black Hat network, so it's open, there's no encryption, and we're not using 1x. If this was a 1x network, you'd see all the kind of EAP goo sitting below that. So these profiles are not much easier to manage. You can manage them in a text editor, you can export them into different tools, you can move them back and forward through group policy or through command lines. Another difference with profiles, in XP, every single wireless profile, anyone can create one on a machine, and then they're available for anyone to connect and use. Typically, that's really what people want to do, but there are a few corner cases where you actually want to lock down. An example of this would be a shared laptop, where if I took it home one night and set up my home access point, configured my network on it, I wouldn't necessarily want the person who took it home the following night to be able to connect to my home network. So you do have the ability to kind of lock it down, so you can have profiles that are per user, and then anything that's machine-wide needs to be, you need admin privileges to modify. Another interesting thing there is we have permit and deny lists. So permit list is basically a list of SSIDs, and these are the only ones my client can connect to, and a deny list is the opposite. I can connect to anything except the ones in this list. So what can you mess with at this layer? So the extensibility at the service layer was really targeted at IHV developers, guys that are writing drivers but also want to do some user mode code. They have some of their own security method they want to implement. They have something to do, some special power management, that kind of stuff. So they can build an extension DLL. We load it into a host process. It communicates back and forward with the wireless service. They can talk down to the driver, and they can also talk up to the UI. So as we go through the kind of connection process, we go through association and authentication. At each of those stages, we actually call out into the IHV extensions and say, do you want to take part in this? A typical way this might be used is if a vendor wanted to implement their own 802.1x security. When we call out for the authentication stage, they can talk down to the driver and say, basically pass on a filter and say, now I want all 1x packets to come to me instead of to the built-in EAP supplicant. When they get those packets, they can either do 1x completely, or if they just want to say do key management, they can actually call back into our 1x engine and drive us. We'll do 1x, they do the key management stuff. Typical things this might get used for is, say, CCX. If they've implemented their own custom service, their own custom security, they're going to have their own set of failure cases. So again, they can kind of plug into that diagnostics and ripple it up to the user. And they can also plug into ePost and add in new EAP methods. We're not recommending any of these, but if your deployment needs them, this is an easy way where you can get new EAP methods onto the machine, and there's a new certification process being built for EAP methods. One thing you notice is that obviously we've added more stuff. There's more connectivity around the base service. There's these new extensions. They're actually running a separate process. Whenever there's a piece of third-party code, whether it's an IHV extension or an EAP method, we're actually going to run that in a separate process, going to control the life cycle of the process. And then if there's any kind of failure in that code, we're going to roll back on an RPC failure or a timeout. So we want extensibility, but we also want to make it as robust as possible. Another thing to point out is that kind of as we're going through this design, you'd heard some earlier talks about changing the mindset of how we're thinking about these things. So part of the design here was as we're looking at say the IHV extension host, we were going through, well, what can you do that's malicious there? Obviously, how can I insert my own code into there? How can I register my own DLL? Is it possible to overwrite someone else's DLL and inject my code there? What about those RPC endpoints? Can I get to them from another machine? Can I spoof one of those endpoints? Do I need authentication? So all this kind of stuff was done in the threat model, and then we try to make sure that there's a mitigation in the code, and it also reflects back into the test cases, so that a test actually does come back and actually make sure that we did fix it properly.
Question?
Yeah.
Why was TTLS not to be part of the core package?
The reason we have a set of EAP methods that A, we think are secure, and B, that we have IP rights for. The question was why isn't TTLS part of the built-in platform? And the answer is largely because of, I think in that case, of IP rights. So we have made a program available so that there are different vendors that own IP for these kind of methods are actually providing them for Vista. So that they will be available, they just won't be built into the platform.
So I would like to add, you'll see in the next, after Vista ships in the next 6 months or so, you'll see a bunch of methods coming online because we are already engaged with them. We have a new framework in Vista, which is not part of this talk, but it's called ePost framework. And it makes it extremely simple to add new EAP methods. And you should probably see something coming up through third parties in the next 6 months or so from Vista.
And again, because we just got an XML format, it's really easy to extend. So if they've done something custom and they need to install their own configuration, they can send it off. We'll move it around through group policy or scripting or whatever, and then pass that information back to the IHV when they need it.
This is the same for the 32 and 64-bit?
Yes.
Yes.
So the availability of drivers may not be the same, but the model is the same.
The drivers for Vista, all the Vista drivers are required to be 64-bit. So for legacy, you may not be able to have a 64-bit driver, but every driver on Vista will be 64-bit capable. And we do have a bunch of drivers which are inbuilt, and most of the major vendors out there, you'll be able to find drivers for them.
So the next layer in the stack is where we have the wireless applications. So in XP, that's basically the building UI. We still have a standard UI for Vista. Does the management to get the view available network list where you see the list networks you want to connect to, advanced UIs for configuration, managing the preferred list to see which networks to connect to in what order. But also you see that the media center have their own specific UI experience that they're interested in a kind of 10-foot display, a TV where you can work with remote control, so they just want a different experience. And then we've also added command line support, so most of the things you can do, and in fact, you can do through the UI, you can do command line, and in fact, many things you can do through group policy, you can also do through the command line. And then the main reason we can do this is because we've opened up that entire area, that entire API layer that sits on top of the service is now completely public and documented. So all our UI, all our controls use a public interface. Before we had some vendors that had done some connection managers and they'd reverse engineer some of the UI, some of the interfaces, which is fine, but those interfaces weren't designed to have multiple clients talking to them. So you do get cases on XP where there's some instability. In Vista, we try to make sure that's open, so it doesn't matter how many wireless clients you've got running, they'll all see the same information. This is just an example of the media center UI. I'm not really going to do UI demos. You can pick up the CD and look at it yourself. The only one I wanted to kind of say was if you are connecting to an unsecure network, I talked about what happens if you click through and you're not paying attention. You just really want to get connected. All that UI that's coming up is just stuff that's in your face and getting between you and connectivity. We want to make sure that when you get to that last point, you're actually going to have the most secure defaults we can find. You connect to an unsecured network, but we're not going to connect back to it by default. If you just hit close or cancel or next, we're going to have a default set of settings. If you really want to go back and order connection, you actually have to do it implicitly. Another kind of interesting UI that is new for Vista is this kind of categorization of networks. So Abelard in his talk talked about network location awareness. So whenever we see a new network, we're actually going to take effectively a fingerprint of that network, and we're going to store that away, and we're also going to ripple it up to the user. So that there are three categories of networks. First one is a domain network, and in that case, we actually have to do a secure authentication to domain controller. But then there are also unmanaged networks, and you can classify them in two ways. You can classify them as public or private. That information gets stored away with the network, and every time the network gets connected, that information is rippled up to any system service or application that's interested in those kind of events. So they'll get the information about whether it's intranet or internet capable, and it'll get this kind of classification information. So you'll see work and home, they both map to private, and the default is public. So again, if you cancel out of that, it will see public. The typical kind of applications that are built in that listen for this kind of information are things like the media center. If you're at home, it'll open up some discovery ports and it'll look for things like Xbox extenders. You don't really want it to do that at Starbucks. And the another one is the firewall, where again, if you're in a public setting, the file will be locked down into its most restricted setting. One other interesting UI is this network and sharing center. This just gives you a really quick look at just what your kind of common exposure is. If you're doing printer sharing, what files you've got, what file shares you've got open, what's been exposed off the box. So it's a kind of quick snap view where you can get an idea of what your exposure is at any time. Another area is we've added command line. I'll show that because it's easier. So in Abelardi's talk again, he mentioned the net shell, which is our command line. It's basically a shell for network commands. You can dive pretty deep into it, and it allows you to extend it with new context. So for all of the networking technologies, there's a net shell context. You can look at the IP stat, you can look at the HTTP server, you can look at the firewall, and you can look at settings, and you can make configuration calls. So we have a new context called WLAN. A bunch of different things I can do in this. For example, I can take a look at what the drivers are. I can look at profiles. I can also take a deeper look at a profile. So if I want to see actually, I haven't got used to typing on this keyboard yet.
Oh, it's black backed.
So this will give you a kind of more human readable version of what you see in that XML file. I can also do things I can look at networks. So this will just give me a quick view of all the networks I can see. And if I want more rich information, I actually want to see the access points, again, I can call that with a different mode. And now I see information about all the access points as well. So this is the kind of information you might see in something like NetStumbler or Kismet. It's just built into the command line now, so you can get a quick view wherever you are. So if you have a machine that doesn't have any tools on, you can still get this kind of information. Other things I can do is I can import and export profiles. And if you're an Uber geek, you can actually connect and disconnect from networks at the command line. And the last thing you can really do here is you can enable and disable tracing. We now have a really rich tracing information that gets stored away. It's kind of useful for application developers, any kind of help desk, or even for forensic information. And later on, True will show you some ways of viewing that. So obviously there's an open API set, so you pretty much can do anything we can do. Connection managers, site surveys, easy connect applications, whatever you want to build at that layer, that API set's now exposed. Because we have now integration with NetShell, this is command line, you can actually script there, so you can actually run scripts down there and control configuration of machines through scripting. And finally, if you have written one of those IHV extension DLLs, so you've got your own customized security or connection management going on at the service layer, you can expose stuff up into the UI. So you can add tabs and pages into our UIs, you can add elements into some of our drop-downs. So there's quite a lot of richness in how you can customize the standard Vista experience. So there's a layer of commonality for users. If they've used one machine, it will look similar on a different machine. But each vendor or OEM can actually have some extensions there for the additional security methods they want to expose.
So I'm going to talk about a little bit more about the WLAN API set. This is the API set which is being used by all the applications that Noel pointed out, which is the inbuilt UI, the command line interface, the media center UI. They all are working on top of this API set. It's a fairly rich API set because it allows you to interact with the service and the driver layer to control them. And most of the APIs are really around connection, configuration, and security. There is also a rich notification API set, so we are actually bubbling up a lot of state information up to the applications, a lot of media information up to the applications, so that you can probably write more wireless aware applications using these APIs. So what I'm going to do here is very quickly switch back to my demo machine, and so what I did was I wrote another application which is built on top of the WLAN API set. So if you don't like the UI that we ship with Vista, if you don't like its capabilities, is it visible? Yeah, okay. So if you don't like the capabilities of the UI, or if you don't like the UI just in general, you can write your own. Let me make sure I can move this stuff here. Okay. So I apologize for the low font. I can't seem to figure out a way to increase the font for this guy. So anyway, if you look at the app, this is very much like some of the apps that you have seen out there, like Kismac or NetStumbler or AP GUI. So essentially, it's showing all the access point networks, all the networks which are out there at the detail of access points. So what you see here, for instance, are 3 adapters. I really doubt if you can read it from there, but what you see here is I have 3 adapters on my machine. I have an onboard Intel 3945 mini PCI NIC. I have a USB NIC, which is an engineering sample from Noel, and I also have a PCMCIA NIC, which is from Realtek. And all 3 of them are the new native Wi-Fi drivers. What you see in the center are all the APs that we are seeing and some good detail about them, like their PHY type, what kind of security they are doing, the channel number, signal strength, etc. All of this information is coming from the WLAN APIs. At the bottom is the notification area where we are printing out some of the notifications which are being thrown through the APIs. I'm just going to select the highest granularity of these notifications so that I can see the top level as well as the media notifications. I can see some more details accompanied with each notification. This application is also a fully functional connection manager, so it can allow you to connect and disconnect from a wireless network. The granularity at which you do it, you can switch to another adapter and pick up another adapter and try to connect to that particular network. So for instance, say I switch to Marvell here and I can pick up a particular network and try to connect to it. One of the ways in which this application extends on top of what we provide on the box is you can actually pick and choose an access point that you want to connect to. You can't do this on XP, you can't do this with the UI that we ship on the box. So you can really pick and choose and say, okay, this is the API I want to connect to. For instance, you see 2 Linksys APs here, pretty common. My home also has 2 Linksys APs. And say mine is the security one, the secure one, and my neighbor's is the insecure one. So I can say that I really want to connect only to my AP. So I hit a connect, I'm prompted for the key. I can type in the key and I got connected to this specific AP. There are some other controls which are there. I just didn't have time to expose it in the application, but you can, like the Wi-Fi driver model or the APIs allow you to blacklist certain MAC addresses. So you can say you are not going to, or you can ask the driver to never connect to certain MAC addresses. You can ask the driver to only connect to certain MAC addresses. You have the control where you can choose the desired PHY type. You're saying, I only want to connect on 11G network. These are some of the examples in which you can really control the driver through the APIs. You can actually, there is an API through which you can put a proprietary information element on the probe request. So you can build some proprietary protocols between 2 devices running Vista. So there's a lot of extensibility and there's a lot of control there, and this application is just an example of how you can use the WLAN API set. One good part about is we are releasing the entire source code for this application. We've got some CDs here, so if you guys are interested, just stop by after the talk or at the booth and you can get hold of one of these CDs. You'll need Visual Studio 5 and the project should just compile. There are also binaries there, so you can play around with the tool, use it as a reference or just extend on it.
It will appear on Microsoft.com eventually. It's just a complete pain in the ass actually getting them to put anything up there.
Yeah.
So that's in process, but it's just not there yet.
Another thing that we have really tried to do in Vista is expose a lot of rich information up to the applications and up to the user. So we want to make the Wi-Fi layer more transparent than what it was on XP. So another logical place where we have exposed this information is the event viewer. So I just opened up the event viewer where we are displaying the wireless information. There is a separate dedicated channel for Wi-Fi events. So you can go there and look at all interesting events along with some useful data. And event viewer is programmable in Vista. There is a good API set called Crimson API set, so you can really write applications on top of it also if you wish. Another place where we have actually tried to expose wireless information is the performance monitor. I don't know how many of you have, I don't know how many of you had a chance to try the PerfMon. On Vista, it has a makeover from what it was on XP. So the new incarnation of the performance manager it's really a reliability, performance, and diagnostics manager. So it was our plugin for wireless in this performance monitor was really targeted for IT admins and for more advanced users or for tech support guys. But the reason I'm talking about it here is that there is some interesting information which might be of some use to you guys. So I'm just going to quickly show you one of the reports that we generate for wireless. So you see there's a wireless plugin here. The typical scenario is there's a user who's unable to connect to a Wi-Fi network. He tries the inbuilt inbox diagnostics. Even then he's unable to connect. There is some problem with the Wi-Fi layer. So he calls up his IT admin or he himself wants to diagnose it further. So you go to this place, you start extended debug logs for wireless. You reproduce your scenario and then you stop it. At the end of it, we produce a nice report which contains a lot of rich information related to Wi-Fi. And looking at this information, you might be able to figure out what is going on, is there an interop issue, or is there something else wrong in my network. There's a lot of rich information here, a lot of forensic information if you want to really figure out what went wrong. So again, I apologize, I don't think you will be able to read it from there, but we bubble up some interesting events on the top. I won't have time to go into everything here, but I just want to quickly bring up the system state where we talk about whether the machine was on power or was it on battery at that time. There's a nice environment info file which has a lot of details about Wi-Fi. So details about the adapter, details about the profiles which were there on the adapter, details about what networks were visible. So this is essentially output of certain NetSH commands. We have some information about the IP layer. What you don't see here is we also dump some meta information about the user and machine certificates, which can be useful in diagnosing some certificate auth-based connectivity issues. If you want more detail, you go to the connection attempts. You can really see some of the attempts that were done by the user. You can open up any of the connection attempts for much greater information. So for instance, I'm expanding my connection attempt. This report was, by the way, run in Redmond, so therefore you're seeing MSFTWLAN and other networks which are there. So you can further expand on any of the connectivity attempts. You can further, so in this particular expansion, you can see we associated with the network successfully, but the failure really happened on the 1x layer. I can further expand on this particular error and I can see, let me read it out. I'm not sure whether you'll be able to read it from there, but what it's saying is that there was a failure. The failure code is hex 50007. Not very useful, but there is a string that goes with it which might be useful, that there was no response to the EAP response packet from the AP. What that means is potentially the link between the access point and the backend authentication server is down. This is typically, when that is the case, then the AP doesn't respond back to EAP response packets. You want greater detail? We have made all the developer logs available. So you can open up any of the logs. We have the driver log, we have the application logs, we have logs for 1x authentication for security. So for instance, I'm just gonna show you the 1x log. So this is really the dev logs, but you can read through the logs. It will give you some insights about how we have implemented Wi-Fi on Vista, and it will give you much better information about really what's going on at the Wi-Fi layer. So I would really encourage you guys to play around with this diagnostics plugin and see if it is any useful to you. So essentially what we have tried to do in Vista is provide a rich API set and complement it with a lot of rich information exposed at different levels. And the hope is that this will be a great platform for you guys to develop security tools, to develop more wireless aware applications, and essentially develop more security software on wireless, on Vista.
So we're hoping, next time we come here that we'll see the next version of the smooth hotspot defender using the new filter, so they'll be able to do things like look for DOS storms or look if someone's trying to do an EAP attack. So I think there's a lot of new opportunity, and we're hoping to see some new tools built on the platform. So in the conference CD, there's a link to where you can get resources to find all this stuff. There's also a couple of aliases you can contact us on. So if you run into any problems, you can't get hold of the tools, just email us and we'll try and help you out.
Switch back.
And then last thing is there's going to be a couple more talks. Adrian's going to do a talk on the heap, and Tony's going to talk about IE7.
Okay, it's there.
So has anyone got any questions, either about stuff we've shown today or the stuff that was in the on the CD that we didn't get to?
Yeah.
Okay. Thank you for listening.
Thank you. Oh, thanks.